Okay, so actually next step would be the simple UART connection. Okay, let's start from showing that how this device actually shows up on computer. So practically when you plug this one in, then let's take a look at the device manager, and under device manager take a look at ports. Okay, we have PSoC2020 COM3. It means that actually you can communicate with that PSoC using port virtual serial port COM3 on a computer, as long as you have the same settings on both ends. So here the default settings is 9600 bits per second, 8 data bits, no parity, stop bits 1, and flow control none. So you need to, of course, define the both ends, both these both this computer side parameters as set in here, so bitrate 57600 and the other parameters the same as you have on your program. So actually this device here, the target device, just a moment, okay, there we go. Target device here, which is on this board right there. The port pins, what were those? Okay, you need to define the target device UART 12.6 as receive and 12.7 and transmit for the UART, and that is actually connected already directly to the pins on this the PSoC. So the PSoC, then actually it's just repeating whatever you are actually sending from the target device. It's repeating as a USB UART bridge to the USB port. So practically now the device looks like, well, this device looks like a COM port, and it communicates directly with this UART. Okay, so, okay, sorry about it. It might be a little bit confusing, but you probably got the idea. So anyways, whatever you send from this device on as an UART will be just repeated as they are on this the USB UART bridge, as long as you have the same parameters on both ends. Okay. So on the PSoC programmer, the designer, you go and continue actually modifying a little bit of this here by going to communications and adding UART on your design. There we go. And change the parameters from here. Maybe name it UART, not just UART1, since you have only one UART here. It's a full UART, meaning both transmit and receive. Okay, and there we go. There we actually have the bits per second is already that 5700 600 as required. 8 bits, no parity, stop bits 1. Okay, and there clock selection, actually you can use either internal or external clock. I suppose you use internal clock. In case you are running short of resources, then you can actually employ this external clock, since then you can use some logic function, a frequency divider, to provide a clock rate for this module and not use the internal clock. So actually this internal clocks that it automatically generates, but it also takes one of the clock sources from the resources, from the common resources. Okay, another things, actually the receive buffer size or transmit buffer size for this application doesn't really make much difference. So this is basically just the first in first out buffer, and the if you had a say time critical system, then you might want to have these buffer sizes bigger. That would then release some resources immediately after you have written the data to the buffer, or so basically you can write or read as bigger blocks, which is good for timing, easier for timing. Okay, but anyways, you do the configuring of it, and then select the pins. In here you do not need to worry about the receive or transmit interrupts, but read the data sheet of this device. Let's see. Read the data sheet, and there you have the application programming interface. You also basically go there and read that one, how to use an UART, but it's quite straightforward. You basically need to enable some interrupts just in case, and then basically you just use the API. Let's take a quick look what to use there on the API. Application programming interface, functions. There is the start. Okay, now we have a component that requires a separate start before you can operate. So when you call the UART start, it actually sets the sets the values so that it has the correct baud rate defined on this the configure window. It defines those, and then it starts the port for operation, and practically then you have the enable receive interrupts, otherwise you probably don't, the buffer doesn't fill or something like that. Maybe I have more information down there, but practically you would be reading the RX register, or wait a minute, you are writing something, so you would be writing. Okay, writing some. Okay, where is that writing? For example, using that one, put string, places string into memory buffer for transmitting. Okay, so let me show you a little bit. Read the APIs and think of what kind of functions they are. And then you can actually do the exercise, which basically you will just modify your program like that. At the beginning, transmit your name. Then you have the software counter. Actually, I do already have it, and incremented by 1 on each blink. Okay, that's also done. If a character is received, the current counter value is transmitted as a okay. Let me copy some of that one here and show you where to put that code. All right, so okay, here you would have the start UART command, for example, there, and then let's see, let me put some comment here. So you have the PSoC transmit your name terminated with carriage return line feed on the beginning of the program. That would be a good place for it. Okay, let me close that and then add software counter. Done. Okay, that's done right in here. Right, that I already have it. Counter is incremented by 1 on each LED blink, which is already, I think, here. Yes, blink. There you go. Done. And if a character is received the counter, so practically what you need to do is to check if there is something if a character has been received, meaning you pressed a key on a terminal program. So actually what you have is you need to have the terminal program. My favorite is PuTTY. Let's see, my COM3 settings is probably the correct. Okay. So practically when I press a key on my terminal, currently it's garbage because of nothing has been sent or received on that port. It's just there, practically some static due to the erratic line changes when I'm plugging in the device. Okay, but anyways, it should operate so that when you press any button here or send a character, in here you will check the status register of USB UART to check if you have any characters received. If there is a character received, then you basically should send the current value transmitted as a string. Okay, now couple of places where I ask you to send a string. So how to convert this uint8 character blink to the string? Well, we can always use the string.h. So we can use the string library from ANSYS. As a ANSYS, well, this is not ANSYS, but actually anyways, quite close the same. You would have the some string operations like, let's see, I think you could here call maybe something like sprintf, which is a formatted printing of data values as string. Okay, So with those hints you should be able to actually send this number as a string, and actually also there I would also put the carriage return line feed. Just to make it a little bit easier, just a reminder that normally the carriage return line feed, the formatting command actually, formatting for carriage returned line feed in format string would be that's the \n is the line feed, and meaning new line, and \r is the carriage return. Okay, so and the formatting string, that would basically add the carriage return line feed to the output. Another thing, of course, here you are printing something to a string. So remember to initialize long enough buffer for the string. Okay, there we have. With these hints you should be able to do the exercise. And on my next recording I will pinpoint some hints on how to return the exercise itself. However, first thing is to make sure that, okay, after the for test, that your system works as described in this exercise sheet.